Click for IB Biology, lipids, and in particular we're going to focus on a group called the triglycerides. Of course, lipids in animals are usually called fats, and in plants they're called oils. Although in animals the oils are present in animals such as fish. So we'll have a look at those. Should you wish, there's a PDF in the description for you to download and annotate your own notes, and a quiz for you to check your understanding of the content. In the formation of the so-called triglycerides, one of the components is this particularly small molecule called glycerol, shown here in two orientations. It's a 1, 2, 3 carbon structure with an OH group on each of the carbons, and I've orientated it this way so that you recognize it when we go to put together and add to it the 3 fatty acid chains. So a very simple molecule. Unlike the fatty acids, which appear to be fairly complex, but if we take a moment, we'll recognize that this is in fact a simple chain of carbons, carbon to carbon to carbon, ending in a carbon double bond to the oxygen, single bond to an OH group. This is called a carboxylic group. A carboxylic acid group is often referred to. And the number of carbons in the chain can vary greatly, from perhaps a dozen to 60, 70, 80 carbons long. So the potential for a great deal of variation in the fatty acids. Notice the relative lack of oxygen in the molecular structure, and this is one of the significant differences that they have with the carbohydrate molecules, where oxygen is far more common. These complex diagrams of fatty acid chains are often represented in alternative methods. Here you can see that each of these groups here, so this is CH3, which is on the end there, that's a methyl group there, and then we have the CH2, CH2, and so forth. So you can count the carbons there, and there is the carboxylic acid group, the C double bond O, and complete the valency by linking to the previous carbon. So C double OH, and you can see here's this is an alternative, much simpler, much tidier form of showing the fatty acid. But the two diagrams below, these illustrate alternative ways of representing the fatty acid chain by using just the zigzag lines, in which we are to understand that at each vertices there's a carbon. Of course, the end one has 3 hydrogens, but all the others have 2, except when we get to here, which of course is the COOH group, and similarly with this diagram here. So there's a whole variety of ways of representing the fatty acids to reduce the complexity of the diagrams and to make them more easily drawn, to be honest. In the formation of a triglyceride, the glycerol molecule, which you can see here, so there's carbon 1, 2, and 3, is going to be joined to the 3 fatty acid chains. But notice the chain, the fatty acid chains have been turned around the opposite way, so that the carboxylic acid group is here and here and here. And that's where the reaction occurs. Another condensation reaction in which 2 hydrogens and 1 oxygen are removed. So we remove the OH group and the hydrogen group and bond through the oxygen. And that type of a bond is called an ester bond or an ester link. And so we have the glycerol is anchoring the 3 fatty acid chains together. The chains, by the way, could be different lengths, and that's where, again, where the variety of fatty acids comes from. In the links appearing now, we'll go on to look at further aspects of fatty acids and their occurrence in biology. And there's a link to the subscription button and also to the playlist for your convenience.